All right, so we've been working on the idea of special right triangles for a couple days now. We're going to wrap it up today. The first thing we started off was talking about Pythagorean theorem, and Pythagorean theorem using leaving our answers in simplest radical form, so practicing that simplifying radicals again. So we did that. Then we went down, did a few practice problems. Then we talked about our first type of special right triangle, which was a square. Well, actually a 45, 45, 90 triangle that comes from a square. So we talked about the properties of a square and why this happened. And then we looked at the special relationships in a 45, 45, 90 triangle, which is also known as an isosceles right triangle. And here we have two relationships. The hypotenuse equals the leg times radical 2. And the leg equals the leg. Since it's a 45, 45, 90, it's also known as an isosceles, which means both of those legs have to have the same value. So then we practiced some questions where we were just working on the 45, 45, 90. All right, then the next we got to the other type of special right triangle, the 30, 60, 90, which the 30, 60, 90 comes from an equilateral triangle. And we talked about the 30, 60, 90. Now we have two different leg measures. We have what's known as the shorter leg, which is opposite the 30-degree angle, and the longer leg, which is opposite the 60-degree angle. And the two relationships here is the hypotenuse equals 2 times the shorter leg, and the longer leg equals the shorter leg times radical 3. And then we practiced some problems dealing with that. Now, this last set is really just mixed practice. 13, 14, 15, 16, 17, and 18. We have both types here. So we're going to kind of do this in steps. The first step that I would like you to do is go through and determine, is it a 45, 45, 90 or a 30, 60, 90, and just mark the sides of the triangle. I'm going to pause for a few minutes, walk around while you do that. So number 13, we have a 90-degree angle and a 30-degree angle. So what has to be the measure of the other angle? If they have to add up to 180, and we already have 90 and 30, the other one has to be, it has to be 60 degrees. So I have a 30, 60, 90 right triangle. The hypotenuse is always opposite the right angle, so X is going to represent my hypotenuse. Now, in a 30, 60, 90, I have a shorter leg and a longer leg. Would the 4 represent the shorter leg or the longer leg? Shorter, it's opposite the 30. So this is going to represent the shorter leg. That's going to represent the longer leg. Now, the two equations that go with a 30, 60, 90, and again, we're not solving yet. I'll give you a chance to go back and solve. This is just making sure we set everything up correctly. Is the hypotenuse equals 2 times the shorter leg, and the longer leg equals the shorter leg times rad 3. Again, I didn't ask you to solve anything yet. I will give you time to go back and solve those, and then we will check. Number 14, I have a 45 and a 90, so the other angle has to be 45. That's the only way it can all add up to 180, which also means this is an isosceles right triangle, so I know that these two legs are congruent. Opposite the right angle is X, so that's representing my hypotenuse. And because this is an isosceles right triangle, we have leg equals leg in this situation. So here we're using hypotenuse equals leg times radical 2, and leg equals leg. And again, I will give you some time to go back and substitute in and simplify. Just making sure we have the setup done correctly. Number 15, I have a 45 and a 90, which means the other angle has to be 45, which means the legs are congruent. So opposite the right angle is the 8 radical 2. That's going to represent my hypotenuse, which means the other two sides are both legs. And again, the relationship, the hypotenuse equals the leg times radical 2, and leg equals leg. We have to know when to use which equations, which starts with identifying which type of special right triangle we have. Number 16, I have a 60 and a 90, which means this angle has to be 30. Opposite the right angle is x, so that's got to represent my hypotenuse. And again, because this is a 30, 60, 90, that means I have a shorter leg and a longer leg. The shorter leg is going to be opposite the 30, so y is going to represent the shorter leg, and 4 radical 3 will represent the longer leg. And now, because it's a 30, 60, 90, the hypotenuse equals 2 times the shorter leg, and the longer leg equals the shorter leg times radical 3. All right, number 17. 60 and 90 means the other angle has to be 30. Opposite the right angle is the 18, so that represents the hypotenuse. Opposite the 30 is n, so that represents the shorter leg, leaving m to be the longer leg. So again, my relationships here, hypotenuse equals 2 times the shorter leg, longer leg equals the shorter leg times radical 3. And then number 18, we have 45 and 90, which means the other angle has to be 45 degrees, which means I have an isosceles right triangle. Opposite the right angle is u, that has to be my hypotenuse, and the other two sides are both legs. So the hypotenuse equals the leg times radical 2, and leg equals leg. So now I'm going to pause again while you go back and substitute back into there and simplify, and then we'll check those. All right, so let's see how we did at substituting in and simplifying here. So going back to number 13, when I substitute in, I get x equals 2 times 4. So x has a value of 8. Then substitute in y equals 4 times radical 3. Radical 3 can't be simplified. It's a prime number. There's no perfect squares. So y just equals 4 radical 3. Number 14, substitute in, we get x equals 3 times radical 2. And again, radical 2 cannot be simplified, so x equals 3 radical 2. And since leg equals leg, y equals 3. And the reason I put the leg equals leg out there is that usually is what gets missed when answering a question, is students forget to tell me what the other leg equals. So if we get in the habit of that being one of our equations, we're less likely to miss answering that question. All right, number 15. This time they gave me the hypotenuse. The hypotenuse is 8 radical 2 equals my leg. It doesn't matter if you use u or v in this case. I'm going to go with v times radical 2 because u and v will have the same measure. To get v by itself, I have to divide both sides by radical 2, which gives me v equals 8. Leg equals leg, so u equals v, but again, we just found v was 8, so we can substitute that in over here to get that u also equals 8. Number 16, x equals 2 times y. Now, when I substitute in there, I have 2 unknowns, which means I can't start there. I have to know one of those values first. So now I need to go over to the other equation and substitute and get 4 radical 3 equals y times radical 3. So to get y by itself, I'm going to divide both sides by radical 3. So that I get y equals 4. Now that I know y equals 4, I can substitute that 4 over here and get x equals 2 times 4. So x equals 8. Number 17, when I substitute in, 18 equals 2 times n. So if I divide both sides by 2, I get n equals 9. And then the next one, m equals n times radical 3. Again, we just found n is 9, so we're going to substitute that in to get m equals 9 times radical 3. So m equals 9 radical 3. And then number 18, the hypotenuse u equals the leg of radical 2 times radical 2. Anytime I have a radical times a radical, I can multiply the numbers underneath the radical together. So u equals the square root of 4, because 2 times 2 equals 4. Square root of 4, 4 is a perfect square, so u equals 2. And then for leg equals leg, v equals radical 2. So again, the first thing you should do is identify, am I dealing with a 30, 60, 90 or a 45, 45, 90 triangle? And then the relationships. Now remember, the homework you're about to get will also have Pythagorean theorem on there. Don't make up assumptions about angle measures that they don't give you. In geometry, we cannot assume anything.